Hi, I'm Joshua Lee, and in today's video, we'll be talking about carbon dating. Carbon dating, also known as radiocarbon dating, is a common method that many scientists use to find out how old fossils are. The concept behind carbon dating is relatively simple. Although there is no clear border, Earth's atmosphere is about 300 miles thick. Most of it is made of nitrogen, which makes up about 78% of the atmosphere. 21% is made up of oxygen, and carbon dioxide makes up about 0.04 to 0.06%. A very small portion, about 7.56 times 10 to the negative fifth percent, is made up of radiocarbon, or carbon that is radioactive. Specifically, we'll be looking at carbon 14. There are three types of carbon on our planet: carbon 12, carbon 13, and carbon 14. Carbon 12 is like normal carbon, it has 6 protons and 6 neutrons. Carbon 13 has 6 protons and 7 neutrons. Carbon 14 has 6 protons and 8 neutrons. The only difference is the number of neutrons. So, carbon 13 and carbon 14 are isotopes of carbon. An isotope is a variation of an element that has a different number of neutrons than protons. Carbon 12 and carbon 13 are stable, so they won't decay. Carbon 14, however, is radioactive, so after a certain amount of time, it will decay. So how is carbon 14 formed? On Earth, the upper atmosphere is constantly bombarded by cosmic rays from the sun. These cosmic rays knock protons and neutrons off of some atoms and into other atoms. Nitrogen 14, which is a normal nitrogen atom, has 7 protons and 7 neutrons. When it is hit by a neutron, it gains a neutron and loses a proton. So now it has 6 protons and 8 neutrons. This is no longer a nitrogen atom since it doesn't have 7 protons. It's a carbon atom since it has 6 protons. Specifically, a carbon 14 atom since it has 8 neutrons. As we mentioned earlier, carbon 14 is an isotope of carbon 12. Carbon 12, since it's stable, can be found much more abundantly than carbon 14. Scientists assume that the ratio between carbon 12 and carbon 14 atoms in the atmosphere stays the same. You should remember that for now. Plants breathe carbon in, animals eat the plants, and we eat the animals and plants. So, the carbon in the atmosphere gets into almost all living organisms. The ratio between carbon 12 and carbon 14 atoms in living organisms is assumed to be the same ratio as carbon 12 and carbon 14 atoms in the atmosphere. To understand carbon dating, you must understand the concept of half-life. The half-life of a radioactive substance is the amount of time it takes for half of the substance to decay. Carbon 14 has a half-life of 5,730 years. So, if you have a bunch of carbon 14 atoms, after 5,730 years, or one half-life, half of it should be decayed back into nitrogen. After 11,460 years, you'll have a quarter of the C14 atoms that you originally had. After 17,190 years, you'll have an eighth of what you originally had, and so on. When an organism dies, it stops taking in new carbon, so the carbon 14 should start decaying. Even in organisms that are currently alive, the carbon 14 is constantly decaying. You won't notice though, since the carbon 14 is constantly being replenished. Scientists reason that if you compare the ratio between carbon 14 and carbon 12 atoms in a fossil to the ratio between carbon 14 and carbon 12 atoms in the atmosphere, you can find out how long it's been dead for. If the ratio found inside the fossil is half of what's found in the atmosphere, the fossil should have been dead for one half-life, or 5,730 years. If it's a quarter of what's found in the atmosphere, it should be dead for two half-lives, or 11,460 years. Although the predictable decay rate of carbon 14 is what allows us to do carbon dating in the first place, it's also one of the limitations of carbon dating. In theory, if you keep taking the half of all the carbon 14s, you'll never run out of carbon. But in real life, there is a point where all the carbon decays. Carbon dating takes about 9 half-lives, or about 50,000 years, to completely decay. For any fossil that is older than 50,000 years old, there is too little carbon 14 in it to measure how old it is. So carbon dating is said to work for any organism that is less than 50,000 years old. Unfortunately, carbon dating is a pretty unreliable method of dating fossils. Let's say you try to pour water into a barrel that has a hole in it. If you pour at a steady rate, eventually you'll hit a point called equilibrium. After you hit that point, you won't be able to fill the bucket any further unless you pour faster or patch the holes. Earth is kind of like the barrel. It is creating and losing carbon-14 at the same time every day. Scientists also realized the equilibrium problem and calculated that Earth's carbon-14 would reach equilibrium within 30,000 years. After that, carbon-14 levels should stay constant. However, at current rates, carbon-14 is being produced roughly 28 to 37% faster than it is being lost, meaning that Earth has not reached equilibrium yet. This would mean that Earth has to be less than 30,000 years old. However, scientists are assuming that the carbon-14 levels in the atmosphere are staying the same, which is not true. So an organism that lived long ago lived in an atmosphere that had less carbon-14 than the atmosphere in modern times. Today we learned about the concepts behind carbon dating. This lesson should be interesting for anyone who likes chemistry or earth science. I hope you all stay curious about science. See you next time!